Hi. Today we're going to cover off the Allison automatic transmission hydraulic control circuits. You guys have already covered the mechanical components. You've taken the transmission completely apart, put it back together again, or if you haven't completed that yet, you soon will be. You do understand, though, I'm sure, how power is transmitted from the torque converter, goes down the turbine shaft into the transmission, where you need to have at least, or you have to have two clutches engaged for the machine to either go in the forward direction or to go backwards. When you're in neutral, you know that the first clutch is applied, and that's the only one that is applied. Why is that? That's because you need some sort of resistance to flow to develop pressure. And pressure is the key to the Allison automatic hydraulic control circuit, because that is what changes and allows this transmission to shift automatically. Pretty simple concept. And because you've already had at least 3 weeks of hydraulic training where you've worked on hydraulic flows and pressures and valves, you've looked into how pumps work and how motors work and all that kind of stuff, you'll probably be able to understand the Allison hydraulic transmission quite easily. Today, we're going to just cover off the very basic concepts that will allow this transmission to start in neutral and shift automatically through its ranges. And I'll cover from neutral into first, because as it goes into second, third, and fourth, it's the exact same component or process, and it uses the same types of valving to cause the shifting to occur. So it's pretty straightforward, easy stuff. And we'll also take a quick look at the schematic that you guys will be coloring in on your own, just to give you guys an idea of how simple it really is. Okay? Let's take a look now, though, at the hydraulic components in the form you guys understand through schematics. Okay, let's take a look now at how the hydraulic components in the Allison automatic transmission directly relate to what you guys have already learned in hydraulics. First of all, what causes the flow in a hydraulic system? It's the pump. So we have here our fixed displacement pump. It has a hydraulic reservoir, not variable, just like any other hydraulic pump you could find. This one happens to be a gear pump. We also have a pressure regulator or a relief valve, depending on its purposes, but that's also a component in the Allison automatic transmission. We have a variable rate orifice. This is the heart of the automatic features in the Allison transmission. There's actually two of them, but we're only going to talk about one variable rate orifice called a governor. We have a pilot-operated sequencing valve, which means to say that when the pressure is below a certain level, oil goes through one path. As pressure increases, this valve shifts over to cause pilot oil pressure to go somewhere else. In an Allison automatic transmission, this is called a shift signal valve. The shift signal valve causes this valve, which is also a hydraulically controlled valve that's spring-centered or spring-returned, and it controls direction. So flow is either going to one clutch or another clutch. This is called a relay valve in the Allison automatic transmission. And this pilot line here is controlled from the position that this shift signal valve is in. So then again, very simple, basic two-position hydraulic valves. What does this valve do? This valve causes a piston to move. And it's a single direction piston with a spring return. I added in violation to the laws of schematics, a simple multi-disc clutch pack on the top just to illustrate what this piston actually does. And that is it squishes the multiple disc clutch pack, either causing a shaft to stop turning or to cause two shafts to rotate together. Okay? And that's all there is to it. So let's take a look at that on an actual schematic. When in neutral, the hydraulic flow in red goes to the governor and also to the first clutch via the yellow line. When the gear selector is placed in drive, forward clutch is activated via the orange line. The purple line from the governor forces the shift signal valve to move. The blue line is pilot oil forcing the relay valve to move. Second gear is achieved because the relay valve sends oil via the green line to the second clutch. First clutch is now drained off. It will shift in the same manner all the way up to fourth and downshift automatically too as speed decreases. So thanks for listening, and stay tuned next time.